Okay. Yes, after we have the basic analysis, next we will conduct a further study. Okay. Because the further study based on the conclusion that the factor has significant impact on the dependent variable. For this test, here it shows that the F value is 5.119 and the corresponding significance is 0.025, which is less than 0.05, right? Hence, the level of libido has significant impact on Viagra. Okay, so if we have this conclusion, that means the dose of libido was a significant effect of Viagra, then we will have further study. Otherwise, we will stop here and draw conclusion that the dose of libido has no significant effect on Viagra. Okay, we will stop here. We will have no further study. Since right now we have the conclusion that the dose of libido was a significant effect of Viagra, then next we want to know which level they have the significant difference. Okay, because we don't know which groups differed. We don't know what the effect of Viagra was. So we could further analysis to find out what the effect of Viagra was. So first, through the mean plot, yes, I showed you the mean plot. From the mean plots, yeah, it shows that this is tended to be a linear line, right? It looks like has a linear trend, has a linear trend. So we want to test if with the dose of Viagra increase, if the libido increase. So we want to test it. This is the trend analysis. Okay, it's called polynomial contrast. Analyze here. Compare means one-way ANOV. Yeah, we will keep all of these things, and then we select contrasts here. Here we have the polynomial. Degree, we have the linear degree, and also we have a quadratic degree. If you select linear, then it just conduct the linear test. If you select quadratic, then the computer will output the quadratic test and the linear test. Okay, so we would like to select quadratic, because if we choose this, it will output both linear and quadratic. Okay, then select continue here. Okay. Okay, because the former part we have already used. Then we will look at the result here, right? Okay. Yes. Where will we see the result? Look here. It has a linear term, contrast, right? Contrast, yes. Please look at this row. This row, okay? The F value is 9.966. The corresponding significance is 0.008, right? 0.008. So it's less than 0.05. Okay, so that means the mean of the it has the linear trend. So that means the linear trend is significant. Okay. Yes, because the F value is 9.966, and also the corresponding significance is 0.008. It's less than 0.05. Therefore, we can say that as the dose of Viagra increased from nothing to a low dose to a high dose, libido increased proportionately. So that means the linear trend is significant. Okay. Next, let's look at the quadratic. The quadratic, the F value is 0.271, and the corresponding significance is 0.612. 612. It means, so that means it's more than 0.05. So we can conclude that the quadratic trend is non-significant. It's more than 0.05. So the quadratic trend is not significant. Okay, so this part is very important. This is the result of trend analysis. Okay, the F. No, F is just like the T value, just like T value, the SW value. Yeah, it's a statistic. It's a statistic value, okay? And just like T value, SW value, it's a statistic. T value, when we use the independent t-test or one sample t-test, we all use T value, right? So here, when we use one-way ANOV, yes, we use the F value, F ratio. We also call it F ratio. So somebody wants to know how to calculate the F value. Okay, F value is the means the sum of squares. Sum of squares is 20.133 divided. Let me see. The mean square and the sum of square within group. Okay, it's the mean square of between groups 10.067 divided by the within groups mean square 1.967. This value divided by this value is the F value. Okay, F value is this divided by this. So larger the F value, more significance. Okay? Okay, so here is the result analysis. Okay. Yeah, that's what I told you right now. Okay, these comparison tests, whether the means increase across groups in a linear way. That's the linear trend. Okay, so for the linear trend, the F ratio, or you can say F value, is 9.966. And this value is significant at 0.008 level. Why? Yes, it's a different way to say, okay. Also, you can say the F value is 9.97, and the corresponding significance is 0.008, which is less than 0.05. Yeah, hence the linear trend is significant. Okay, so also you can translate this sentence into another way. Okay, understand? Okay, you can say that it's equal. Okay, yeah, the F ratio is 9.997. The corresponding significance, or p-value. Yeah, also you can say p-value. Corresponding significance is 0.008, which is less than the 0.05 level, right? Okay, so hence the linear trend is significant. Okay. Yeah, they are equal. Okay. This sentence equal to this sentence. Yeah, you can say this sentence, or also you can analyze like this. Okay, they are the same. Okay, therefore we can say that as the dose of Viagra increased from nothing to a low dose to a high dose, right? Libido increased proportionately. Okay, and then next is the quadratic trend. The observed significance value is 0.612, which is more than 0.05. So we can say that the quadratic trend is non-significant. Okay, so please look at here to test the linear trend, and look at the result of this row. Yes, so for your quadratic trend analysis. Okay? Okay, if you have no question, then we will continue. Any question here? Can you understand? Okay, if you have no problem, then next further study. This is the first further study, trend analysis, because from the main plot, we think it looks like, yeah, it looks like it has a trend, linear trend. Then we will test if it's really have linear trend, because sometimes maybe the plot shows looks like has linear trend, but in fact the linear trend is not significant. Okay, so next we will continue our further analysis. Second further analysis is multiple comparison. what's the multiple comparison will be used? It will use which level has different means. Because sometimes we have 3 levels, and the level 1 have significant difference with other 2 levels. Or sometimes maybe 1 and 2, 1 and 3, 2 and 3, they all have different, the means of these 3 levels are different. But now we have no idea. Okay, so we want to use the multiple comparisons. Multiple comparisons, look at here. Here we can see 2 groups. Okay, yeah, just like the first step, because we have test the variance if it's equal or not equal. If the variance is not equal, then we will use this statistic value. Okay, we will use these methods. If the variance is not equal, then we will use these 4 data. Okay, you can select this or this or this or this. Okay, it's different. Okay, but for this, in this case, after we test the variance of 3 groups are equal. So we can use this to test. Okay, yeah, and yes, since we have different methods, so you should know which method is suitable for you to choose, right? Okay, so here is the guidance. Here's some suggestions. Okay, firstly, if variance equal or not, yeah, this I showed you, right? And second, the sample size equal or not. And if the sample size equal, what does sample size mean? It means level 1, how many cases do we have? Level 2, how many cases do we have? If the number of cases are same, then it means the sample size are same. Okay, so let's check. For example, here, no, not this one. We would use the cross tabs here. The participants, the dose of the Viagra. Okay. Sorry, it's not this thing. Yeah, look at here. We have 5 placebo, 5 low dose, 5 high dose, right? Here's the frequency. So that means 5 respondents, placebo. 5 people, they use the low dose, and 5 people use high dose, right? So that means all the sample sizes is the same, okay? Yeah, placebo 5, low dose 5, high dose 5, so that means the sample sizes are same, equal, okay? If they are equal, then we can use REGWQ, Turkey. Okay, these 2 methods are suggested because Turkey They are widely used in the multiple comparison. Okay, if the sample size slightly different, then you can use Gabriel. For example, we have 5 people in level 1, 6 people in level 2, 7 people in level 3. Then the sample size is just slightly different. In this case, we can choose Gabriel. Okay. If the sample sizes are very different, for example, one sample we have 5 cases, and another sample has 100 cases. No, 100 cases is too much. One is 5 cases, and another is 20 cases, and another is 30 cases. So here you can see that the sample sizes are not equal, are very different, right? Then you'd better to use this GT2. You can use GT2 for your analyze, okay? Okay, since here they are equal, right? Then we can use U, because other methods, the bound farina is conservative. Okay, and LSD, yes, there is just opposite of bound farina. SCIF is conservative, but lack statistic power. LSD has statistic power, but it's not conservative. Okay, and the Turkey is in the middle. So we would like to use Turkey because it's not very, the statistic power is medium and the conservative is medium. So we would like to use these 2 methods. Okay, and if the equal variance are not assumed, then we will use this. Also here, we would see the sample sizes are same or not. Also here, the T2 is conservative and T3, DC, keep a very tight type 1 error rate control. And the GH is the most powerful. Okay, so they are different. Okay, they have different features. But if the sample sizes are unequal, this method is suggested to select. Okay, so if the sample sizes are not equal, yes, please select this. If they are equal, then you can select all of them. But sometimes we'll select T2, sometimes we select T3, and sometimes we select C. Okay. Okay, because the Viagra data they are equal sample size and equal variance, then we can use Turkish test and REGWQ. And also, we can check the findings with the GH procedure. Okay, we could use NET test to examine. Okay, so first we use this, and compare with this. So which method you will use, it depends, right? So here is the post hoc. Post hoc, yes, according to the suggestion, Turkey, right? And besides Turkey, next, we also want to select the REG. REGWQ is here. And then we will compare with this. Okay. And also we choose the donut. The control category is the first. Why? Because the first is placebo. It means no libido. So we want to know if we use libido or we not use libido, if they are the same. No, if we use the Viagra or we don't use Viagra, if they have difference. So we will choose the control categories first. If we chose the control category first, so that the low dose of Viagra will compared with the placebo. Also, the high dose of Viagra will compared with placebo. Okay, so in this case we will choose the first, not the last. Okay, because you chose first or last, it depends on your test. What you want to know. Then here continue. Okay. Here shows the result. Okay. Yes, and I saw that all of you have completed it. That's good. Okay. But the more important thing is you need to analyze it, right? Okay, so from here, see, this is the groups they compared. When we compare placebo and the low dose, the mean difference is -1, and the significance is 0.516, which is more than 0.05. So that means the placebo and the low dose has no significant difference. Next, placebo and high dose, when they compare, the mean difference is -2.8. The corresponding significance is 0.021, which is less than 0.05. So that means the high dose of Viagra and the placebo, the mean of libido has significant difference. Also, you can see a star here, right? Okay. Then here, we can compare the low dose and the high dose. The low dose and the high dose, the mean difference is -1.8, and the corresponding significance is 0.147, which is also more than 0.05. So that means the high dose and the low dose, they have no significant difference. From here, we can see that why the one-way ANOV is significant, because the placebo group and the high dose group, they are significantly different. Okay. Yes. Also, when we use the Games Whole-Ware, the result is the same. The placebo low dose has no significant difference. And the placebo high dose has significant difference. The low dose and high dose, no significant difference, right? Okay. Also, the donut, two-sided, low dose and placebo, no significant different. High dose placebo, significant different, less than 0.05. Right? Understand? Yeah. Also, here is the homogeneous subsets. Homogeneous subsets. This table shows the result of the Turkish test and the REG-WQ test, right? Yes, here is subset. Look here. Here is group 1, here is group 2. It means placebo and low dose, they are all in the group 1. And low dose and high dose, they are in group 2. If they are in the same group, it means they have no significant difference. They have no significant difference, right? Low dose have no significance with placebo. Low dose have no significance with high dose, but placebo and high dose, they are significantly different because they are in 2 groups. Also, when we use REGWR method, yes, the result is the same. Low dose and placebo, no significant difference. Low dose and high dose have no significant difference. Placebo, high dose, they have significant difference. Okay. Here is the multiple comparison. Hope you all can understand. Okay. Okay. Next is the planned comparison. Okay, also, yeah, further analysis. Second further study is comparison, multiple comparison. And the third further study is planned comparison. So next we will continue. Okay. That's the planned comparison. Okay, here, this is the our last lecture. Okay. What's the planned comparison will be used? If you have a specific hypothesis that you want to test, the hypothesis must be derived before the data are collected. Then you can do planned comparisons. For example, from our experience or from other researchers, their conclusion. Yes, you already have the conclusion and you want to confirm it. You want to test if you can also have the same conclusion. Then the hypothesis derived before the data are collected, we do the planned comparison. Okay, step 1, decide which comparisons you want to do. Step 2, what weights must be assigned to each group for each of the contrasts. For example, hypothesis 1, taking Viagra significantly increased libido compared to the placebo group. Yes, we want to test if taking Viagra significantly increased libido compared to the placebo group. Now, when you look at the sentence like this, tell me which group compared to which group? Taking Viagra, in this group, we have two levels. One level is low dose of Viagra. Another level is high dose of Viagra, right? And the placebo group, we just have one level, which is placebo, no Viagra, right? Okay. So here, this group have low dose of Viagra and high dose of Viagra. This group, placebo. Okay. After you have this in your mind, then you start to analyze. Okay. So here, Viagra, analyze, complements. One more interval. The pestihawks, I will remove them because I don't need them. In this time, I use the contrasts. Okay, not this one, but here. Here, the coefficients is for the libido. The libido, the first is placebo, right? The first is placebo. The placebo is one group, so we will use 1 for the placebo. This is the coefficients for the placebo. We add it. The second is low dose of Viagra, and the third is the high dose of Viagra, right? So in this group, we have 2 levels, and each level, the coefficient will be 0.5, because 0.5 add 0.5 is equal to 1. Okay, and also because it's another group, then we will use minus 0.5. Minus 0.5. It means this is one group. This is another group. Okay. After this, continue. Continue. Okay. Yes. Please look at the contrast coefficients here. Because this time we will test taking Viagra. If taking Viagra has significant difference with the placebo, no Viagra. If half Viagra is different with no Viagra, then we will use the placebo. The coefficient is 1. Low dose minus 0.5, high dose minus 0.5. If when we compare one group and another group, when we summarize, we will add all the coefficients together. It should be 0. Okay, when we add all the coefficients, they should be 0. And the one group and another group, they should be the same. Here 1, here minus 0.5, minus 0.5. Okay, and then here is the result of contrast tests. Okay, where can because here also have 2 rows, right? We have 2 rows of results. So which row we will use? It depends. Look here. If the equivalence assumed, then we look at the upper row. If the equivalence is not assumed, then we look at the lower row, right? This time, in this case, because the equivalence is assumed, so we look at the upper row. Here, the t-value is minus 2.474. The corresponding significance is 0.029, which is less than 0.05. It shows placebo. The dose of Viagra has significant difference between placebo and having Viagra. Okay, understand? Understand? Okay, so look at the result analysis here. Okay. Yeah. Okay. If the contrast one is Viagra, if Viagra significantly increased libido compared to the placebo, right, then you need to use 1/3. If the hypothesis, null hypothesis, the Viagra significant, the Viagra increased libido has the mean of Viagra, the mean of libido when we use the Viagra or not use Viagra has no significant difference. If that's the null hypothesis, then we use 2/3. If the hypothesis is significant increased, not a significant different, increased, it means the Viagra, when we use Viagra, the libido is more than when we don't use the Viagra, right? So if the null hypothesis is increased, then we use 1/3. If the null hypothesis not significantly different or the same, then we will use the 2/3. 1/3 or 2/3, yes, when we use the t-test, yes, I think we have discussed them, right? For example, if the 2/3 significance is 0.029, then the 1/3 significance is divided by 2. So 0.029 divided by 2 is 0.0145. Yeah, it's absolutely less than 0.05, right? So that means, yeah, compared to the placebo, Viagra significantly increased the libido. Yeah, we can draw this conclusion. Okay? Okay. Yes, let's look at the second test. Second is let's see the second. Okay, second is a high dose of Viagra increased libido significantly more than a low dose. Look here, more than one low dose, right? So if it's more than one a low dose, so that means it's also one-sided. It's also one-sided. This is one-sided, significantly increased. That's the, yeah, and also here, more than one a low dose. Here is also one side. Okay, and yes, let's analyze. High dose of Viagra, low dose of Viagra. So that means in this group is high dose of Viagra. This group is the low dose of Viagra. Placebo not attend the comparison, right? Since, yes, here we can't see the placebo. So the placebo, when we add the coefficient, the placebo coefficient is 0. Okay, so let's look at here. Here, analyze. Also compare-means, 1 and over here, libido, yes, contrast. Second, okay, remove. Okay, so placebo, we will not compare placebo, so placebo is 0, right? And next, we will compare the low dose and high dose. So low dose is 1, high dose is -1. If you would like to use -1 for low dose, then please use 1 for high dose. Yeah, you can use -1 for low dose, 1 for high dose. Yes, they are the same. Okay, continue. Now, loaders is 1, minus is hiders. Okay, so here is please look at the contrast test is this one. Contrast test, since the variance is equal, right? So we look at the upper row. Here, significant two-tiered is 0.065, but for one-tiered, you should divide it by 2. So 0.065 divided by 2 equal to 0.0374. 0.0374 is less than 0.05. So if it's a planned contrast, then we would like to say that the hiders of libido increased the hiders of Viagra increased libido significantly compared to the loaders of Viagra. Okay. Yeah. Yes, please look at the analyze here. Okay. Yeah. Minus 2. It's divided by 2 is less than 0.05. Okay, so in summary, there is an overall effect of Viagra on libido. The planned contrasts revealed that having Viagra significantly increased libido compared to the placebo. Yeah, T12 is 2.47. The p-value is less than 0.05. That's the first hypothesis. And having a high dose significantly increased libido compared to a low dose. The T is 2.03 and the P is less than 0.05. Okay. Yes, that's all for today's course. Okay, and yes, after class, please complete practice 1, practice 2. Okay, also the data file I already sent in Ding yesterday. Please download the practice 2. Practice 1 it's harder because you need to put in the data and establish a data file. Okay? Understand? Yeah? Thank you for listening.